Hello, everyone. Welcome to reInvent 2023, and welcome to our session. Real-time data powers modern businesses today, from e-commerce to automotive to financial services. AWS services are enabling our customers across a wide range of industries to harness value from their data. Real-time data-driven insights are empowering our customers to take more timely decisions, build innovative products that cater to the needs of their customers, and improve efficiency at scale. One such customer and partner of ours that we have with us today is Rivian. And in this session today, we'll discuss how Rivian has built their real-time analytics system that forms the backbone of their electric vehicle data platform. We'll also share with you some of the recent innovations we are doing on AWS that make it easy for you to build such event-driven data pipelines, which are cost-effective and easy to use. I'm Vidhi Taneja, and I'm a Principal Product Manager at AWS for Amazon Managed Streaming for Apache Kafka. I have with me our friends from Rivian, Anirban and Rupesh.
Hello, everyone. My name is Anirban Kundu. I'm a principal engineer at Rivian's data platform team.
Hello, everyone. My name is Rupesh More. I work as staff engineer in the data platform team at Rivian.
Cool. So now, before we get started, we'd love to show you a sneak peek of how real-time data forms the foundation of the driving experience that's offered by Rivian vehicles. Wow. So what we just saw was how real-time data drives Rivian. And what we'll see next is how AWS services are enabling and playing a key role in the data platform for Rivian. Now, to gain value from your data in real time, you need to ingest, store, process, and analyze data that's coming in at high velocity, in high volumes, and from a variety of data sources in real time. And AWS services offer a variety of services, streaming services, that enable you to do that more cost-effectively and easily. One such service that we'll discuss in further detail today is Amazon MSK. Amazon MSK is our fully managed service for Apache Kafka and Kafka Connect. Apache Kafka is a popular data streaming platform that's used by many of our customers in AWS. But then our customers have also been telling us that running Kafka by themselves at high availability, securely, at high scale, can get challenging. So to help with that, we launched Amazon MSK to enable our customers to build such end-to-end data pipelines easily using Kafka on AWS. You can use it in provisioned mode if you may want to have a control on your cluster capacity and configuration, or you can use it in a serverless mode if you rather may want to have a more automatic experience of partition balancing and cluster resizing. MSK is compatible with open source Kafka, So if you have your self-managed Kafka workloads running, you can just move them over to MSK and keep all your existing tooling, integrations, and you don't need to make any changes to your code. It's highly available, highly scalable. In fact, we have our customers that are ingesting over 15 gigabytes per second of data consistently on a single MSK cluster. It's secure by design, and it offers multiple authentication and authorization modes. And MSK seamlessly integrates with a variety of services offered by AWS, such as IoT Core, AWS Lambda, and Amazon Managed Service for Apache Flink. Now, we've been listening to our customers since launch to improve MSK and innovate on their behalf in the areas that matter most to them. Our recent innovations on MSK are categorized in these 4 themes: improving cost efficiency, increasing resiliency, simplifying client connectivity to your MSK environments, and providing a deeper integration with a variety of AWS services. So now let's look at each of these areas in further detail. Cost optimization is a priority for our customers, and they continue to tell us how we can make better cost, or how can we provide better cost economics when they're consuming and storing data on MSK. So to improve price performance of running Kafka on MSK, as of yesterday, we launched the support of Graviton317 instances for MSK clusters. This brings Graviton's innovation, compelling economics, and high performance to Kafka workloads running on MSK in AWS. With M7G instances, you can lower your compute costs by up to 24%. You can get up to 29% higher read and write throughputs, and you can lower your energy consumption by about 60% as compared to M5 instances. We launched tiered storage last year, and many of our customers are already running tiered storage in production environment today. We now are making tiered storage generally available for the latest Kafka version 3.6. Tiered storage offers an elastically scalable, virtually unlimited remote storage tier for your MSK provisioned clusters. It comes all built in, so you don't have to install any additional components. You just have to turn tiered storage on, provide the policies for your retention per topic, and it just works. And you only pay for what you use based on the amount of data you store and retrieve from tiered storage. With tiered storage, you can store data in MSK for longer duration and run high throughput workloads more cost effectively. You can also simplify your data streaming architectures by leveraging the same application logic or code for your historical and real-time data. And now with less data stored in your primary tier and less data required to be moved around, the partition balancing is much faster, and your failure recovery in case the brokers fail is faster as well, requiring lesser resources. Now, many of our customers have already been running tiered storage in production and getting benefits from the cost economics it provides. For example, one of our customers was able to reduce their unit costs by 69% while increasing their retention 3 times. Another customer, FactSet, they achieved 56% cost savings by just turning tiered storage on their existing MSK clusters. Now, the next area of innovation that I'd like to talk about is how we are making it easy for our customers to build highly resilient applications on MSK. We launched MSK Replicator that reliably replicates data from one MSK cluster to another in the same region or a different region. You can simplify data distribution, and you can build cross-region streaming applications if you may want increased availability as well as business continuity. An MSK replicator takes care of installing any components, managing any components that are required underneath, so you can focus on replicating the topics that you may want to replicate without having to monitor or scale capacity. Next, I'd like to highlight how we are making it simple for you to securely connect your Kafka clients to MSK clusters. Now, with a few clicks, you can securely and privately connect your MSK clusters with Kafka clients in any VPC or AWS account while retaining the data in your AWS network. MSK Provision and Serverless, they now support Kafka clients in any programming languages. So now you can use IAM to simplify and standardize access control of your Kafka resources, and we provide helper libraries in some of the common and the popular programming languages such as Java, JavaScript, Python, Go, and .NET. Now, last but not the least, we are committed to investing in native integrations with other AWS services so you can simplify your data movement. You can move data in and out of MSK to a service of your choice. Amazon S3 is a popular destination for our customers to store streaming data for longer duration. And MSK now natively integrates with Kinesis Data Firehose, so you can simplify your S3 delivery with this no-code, fully managed solution. It also offers built-in transformations, and it takes care of any failure handling, guaranteeing you that the data will get copied properly. We now also offer a new connector for Athena, which is supported by MSK Connect. And with that, you can access your real-time streaming data with SQL-like queries. You can also directly ingest your streaming data into Amazon OpenSearch and Redshift, leveraging their streaming ingestion feature without any connectors required. We discussed a breadth of high-impact features that we are bringing to you that make it easy and cost-effective for you to build real-time data pipelines and do it in a more cost-effective way to derive value from your data. We look forward for you to use these features, explore these features, and we'd love to hear your feedback. And with that, let's hear from Rivian on their streaming and analytics journey.
Say hi, ask questions.
Okay.
All right. Is it really?
So when I punch it, do I just floor it? Let's do it.
3, 2, 1, let's go. And now we're gonna go with this.
The scariest thing is going up the hill, because having been in different vehicles in the military, I would never do anything. Like I'd be freaked out.
At Rivian, our motto is adventure forever. We build sustainable adventure electric vehicles, And for that, we have partnered with companies like Amazon to build out this vision. We're also a software and a data company. From day one, we have had a cloud-first strategy, and our ecosystem is built on AWS. They've been an excellent partner for us. Our team manages some of the critical vehicle-to-cloud interface systems like remote commands, notifications to customers, and high-throughput telemetry features. We'll talk about some of these features today in this session. In the last few years since we started production, we have received lots of appreciation from our customers and recognition from industry watchers. As recently as last month, a team driving the Rivian R1 truck won the Rebel Rally, which is a 1,500-mile desert rally across Nevada and California. Shows the kind of vehicles we build. Now, we also have 80,000 vehicles on the road, including 10,000 prime delivery vans being driven around your neighborhood. And today, we'll talk about this ecosystem and how these vehicles do amazing things. Let's take a look. Here are the key ideas that defines us. Software-defined vehicle is the critical underpinning of the whole system. Above the base electrical and mechanical architecture, you have a rich software stack that manages practically all facets of the vehicle, whether it's the powertrain, ADAS, infotainment, telematics, you name it. Software-defined vehicles gives us tremendous flexibility on how we can push software updates to the vehicles almost every month using what we call over-the-air updates. On the right side, right top, you can see the center display in the vehicle with a OTA, over-the-air update, about to take place. This allows us to introduce new features in the vehicle, fix issues, and optimize or enhance the whole experience in the vehicle. Now, at any point of time, there are hundreds of algorithms at play in the vehicle, whether it's at rest or in motion. The image on the bottom right is, again, the center display, showing some of these session summary information, like charging, range, and other critical, useful information. Now, let's take a look at the source of this data. This is what we call the skateboard design, and this is, again, a shared platform for Rivian with some variants applicable for each model. You have about 70-odd electronic control units, or ECUs, for the initial original generation of the vehicle that shares an Ethernet bus, sends the data through what we call the telematics control module over Wi-Fi or LTE to the cloud. Depending upon usage, a typical vehicle would generate about 30 gigs of data. So at this point of time, from the fleet, we are taking in several petabytes of data through our ingestion pipelines. Vehicle data and analytics. This is where our team sits. This includes bidirectional functional APIs, like remote commands, or pushing configuration down to vehicle. Now, the animation on the right shows some of these. This is from the mobile app, shows some of these remote commands taking place, like, for example, closing the hood or venting the windows and other such features. Now, vehicle data includes coarse-grained state of the vehicle, and this could be the charge state, or it could be the interior cabin temperature, or whether the vehicle is in park state or in motion. Vehicle data also includes fine-grained telemetry from the vehicle. And this is like the amount of current flowing through a certain ECU in milliamps, or the vibration from a certain sensor. Now, all of these data is used to send critical notifications to our customers and internal consumers. It is also used for streaming and batch analytics in the cloud to determine any kind of outliers, anomalies, or for trend detection. One such use case at Rivian is the digital twin. The intent of digital twin is to model the vehicle's behavior on the cloud using vehicle data. The purpose is to obtain the lifetime efficiency of the vehicle operating under extreme conditions, like, for example, cold weather testing in Alaska, Norway, or New Zealand, or hot, dry weather in Las Vegas. With this setup, you can inject outlier parameters, faults, and observe the models behave. Now, the key thing is the adapt feedback loop that you see at the bottom, which allows us to reparameterize the ECUs back to the vehicle using what we talked about over-the-air updates. And finally, let's talk about the power of cloud. Once the data lands in cloud, it is parsed, partitioned, anonymized, sanitized, and eventually we create standard data sets. Like, for example, vehicle trips data, OTA data, session data, and so on. And some of these Rupesh will touch upon later. Now, security and privacy is super important to Rivian. Cannot emphasize more. For security, the vehicle authenticates using what we call a mutual TLS with X509 certs, establishes an encrypted pipe, encrypts the data in transit, and at rest when storing in the cloud. For privacy, we only collect data that has been consented by the user for the purpose for which it's consented and nothing more. And this makes total sense as we go to new regions where we have to honor local laws. On the right-hand side, you can see some of the many services that we use, AWS services, including connectivity, ingest, compute, and eventually store. The data sets that are created are now democratized with internal team after applying RBAC and ABAC authorization schemes. And this data is accessible using REST API, streams, or events. For SQL users, we have SQL interfaces that allow you to access this data. The whole notion of connected vehicle model is based on a user experience that extends the vehicle into the cloud. Super important. We don't see the vehicles as independent entities. They're extensions of what you can do on the cloud or via the cloud. Now, let's take a look at two such use cases that we have. Remote command lifecycle. Let's say, for example, you have a vehicle in New York, and you're right now in Las Vegas. You want to unlock the door. You take out your mobile phone, open up the app, establish a bidirectional pipe with the cloud. The cloud tries to determine if the vehicle is online. If it's offline, it reaches out to the LT provider. The LT provider sends an SMS message to the vehicle. The vehicles have eSIM, by the way. The vehicle wakes up and initializes, establishes a bidirectional secure channel. It pulls down the remote command, performs, actuates, and then sends a notification back to the cloud, which is relayed back to your mobile user. One other use case is the geofence breach detection. This is typically used by fleet managers. The purpose of this is to identify if a vehicle has gone beyond a certain geofence. Fleet managers will use some internal tools, create some polygons or circle geofences, upload to the cloud. The cloud will munch this data, create suitable data structures for easy computation. Once the vehicle comes online, it sends a continuous of geofence. Whenever a geofence is breached, as you can see here, the cloud immediately identifies that and sends a notification to the fleet managers. Now, use cases as these are the fundamental value adds that we offer our customer as we continue to leverage the power of cloud. Now, taking the cloud connected vehicle model use cases as business drivers, we apply this fundamental data platform tenets as guiding principles to define our architecture. We already talked about remote commands, notifications, and services that require low latency. So performance, scalability, and cost are critical. Security and privacy, we discussed that. and similarly, data democratization within internal teams like services, reliability, diagnostics, and even engineering. Now, we went about discovering the kind of technology stack that we want to use. The choice of stream processing engine in our case was critical. The key criteria were ability to process a wide variety of messages, resilient to failure, and in case there is failure, should be quick to recover. So with that use cases, we went with Apache Flink running on Amazon's Elastic Kubernetes service. And for ad hoc serverless compute, we went with AWS Lambda. Next, for high-performing data plane backbone infrastructure, the key criteria for us were ability to shard, and this would cover our growth requirements, durable consumers, and our data semantic needs. We also needed an ecosystem of well-supported tools, like, for example, in cases of migration or data replication across regions. And finally, pretty early on, we figured out that we wanted this service to be managed for support, upgrade, and other needs. And for all of those reasons, we went with Amazon's Managed Services Kafka. And apart from that, we also use AWS S3. We have Apache Druid, and services like DynamoDB and DocumentDB. Next, my colleague Rupesh will talk more about the telemetry architecture at Rivian and do a deep dive of how we use MSK.
So today's talk is about the Rivian telemetry architecture, and we will see how MSK powers 4 major pipelines at Rivian. That's like the telematics service, the data lake service, the event watch and notifications pipeline, and lastly, the Amazon last mile pipeline. We will be doing a deep dive into these 4 major pipelines. So on the extreme left, you see a Rivian vehicle. It has a telemetry control module, also known as the TCM, which is responsible for consolidating all the different signals from different ECUs, eventually forming a payload, and that payload gets synced to the sync service in the Rivian cloud. So once the data is validated by the sync service, it is ingested into the raw topics in Kafka. We have a bunch of like Flink pipelines that transform the data as it goes through like different stages. So all these Flink pipelines are hosted in like EKS and are managed by the Apache Flink operator. One such Flink pipeline is the standardization pipeline, which applies a bunch of business rules like masking of the car ID for privacy needs, applying data model, and writes the denormalized data into the Kafka topic. Now we'll focus on the telematics service. So how quickly can you query the signal data once the data is generated in the vehicle? The end-to-end latency really matters for this service. It's an API-based microservice that provides access to the snapshot or the latest state of the vehicle signals, provides access to the time series data of the vehicle signals, and vehicle heartbeat. It is extensively used within Rivian for powering dashboards and UIs. Moving forward and looking into the architecture of the telematics service, so we have a normalization Flink pipeline that normalizes the denormalized data from the standardized topic into individual signal records. So these signal records are written back to Kafka. So this normalized data is again ingested into Apache Druid. To have minimal latency, the choice of the time series data store was really critical. We settled on to Druid because it is like well distributed, easily available, highly scalable, returns query results in millisecond range, have rich API support, hence the choice. The normalization pipeline also writes the latest signal state into Amazon Elasticache. The telematics service is hosted in EKS, and it's like an API-based microservice. This service is heavily used by the reliability and diagnostic teams, fleet and the service management teams, and the right teams. The latest state is heavily used by the mobile team for powering the Rivian mobile application. Talking about the latency, the end-to-end latency for all the Redis queries is less than 100 milliseconds versus for Druid it is like sub-second. So moving forward, looking into the data lake pipeline. So the data lake use cases are to query historical telemetry data, run deep queries spanning for like many months to like year. It's a vast Databricks ecosystem with thousands of Rivian employees relying on it. It has access to like varied data sets that include factory data, manufacturing data, diagnostic data, and service data. It's been used by different machine learning engineers, data analysts, and data scientists to derive insights, perform aggregations, eventually to power dashboards to perform analytics. So this platform enforces authorization on users accessing datasets for privacy needs. Looking into the architecture of data lake, so post the data into the raw topics, we have a bunch of like Spark structure streaming jobs that stream the sensor signal data into Delta live tables in S3. In the Databricks medallion architecture, this forms the bronze layer or the raw dataset. Later, a bunch of like Spark jobs are scheduled daily that creates sessions based on critical signals into individual tables, for example, the charging sessions, the trip sessions, etc. So in the Databricks medallion architecture, this is the silver layer, and which is like a clean and conformed data set. The Rivian reliability and diagnostic teams have created this gold layer data sets with hundreds of custom tables, mostly used to derive insights. For example, specific tables were created for like mileage, OTA status, etc. This transformed data set can easily be queried using Databricks SQL, AWS Athena for quick analysis, for anomaly detection, and easily visualized using preset dashboards. Moving forward, how do we send real-time notifications to our customers? So this event watch and notifications pipeline makes it possible. One such example we want to share with you guys is the pet mode feature within Rivian. So in your Rivian car, you can engage the pet mode feature while traveling with your pets. While you are away from your car, you can set the cabin temperature for your pet between 68 to 74 Fahrenheit. The center information display screen within your Rivian displays the cabin temperature and also the pet mode status. While you're away and your pet is inside your Rivian, you can also check the pet mode comfort feature in your Rivian mobile app. Now, if for some reason there's some issue, or for an unforeseen situation, if there's some issue with the vehicle range being like critically low, or if the cabin temperature gets too hot, or for example, if the HVAC turns faulty, the event watch Fling job detects this defined threshold and sends client notifications back to the Kafka topics. So on the screen, you can see like some of the notifications we have included here. Let's look into the architecture, the event watch architecture. So there are more than like 30 event watch Fling jobs that tracks critical signals and filters notification events into Kafka topics. We have this AWS Lambda that processes these events and uses Rivian core services to send out these notifications. The different types of notifications include the mobile push notifications, PagerDuty, email, and SMS, etc. The event watch framework also manages two critical applications. One is the geofence application, as Anirban already mentioned about the geofence application. So the Fling job within this framework tracks the GPS coordinates from the fleet and publishes in and out events into Kafka topics for notification purposes. For different business-to-business customers who have their own fleet to manage, the framework manages to send the telemetry data from the fleet in real time into the customer's Kafka clusters. And lastly, about the Amazon last mile pipeline, let's first watch the Amazon Rivian partnership video.
The most sustainable transportation fleet in the world. So 100,000 units, that's a large volume of vehicles. We have to get this right.
Oh, wow. we have an opportunity to really set the standard.
It's hard to not notice the changes around you.
We're at an inflection point in human history where our actions are shifting and fundamentally changing the nature of what this planet feels like to live in, so we're changing the climate. The time we have to make that shift is right now.
When you talk about Amazon's delivery fleet, why wouldn't we go electric? And we thought if we took Amazon's package delivery know-how and Rivian's vehicle expertise, and we worked backwards from the needs of the driver, what could we do? It needs to be the most functional, the highest performing, the safest.
Everything you see on the vehicle is a decision.
We'll mill out the clay, we'll see it in full size, we'll color it up, make it look like a real car, and it gives us a quick visual representation of what the vehicle is going to look like for production.
When we succeed, if we displace those gasoline vehicles with an electric vehicle, it'd be a large step forward in making our package delivery business sustainable and that has a positive impact on the environment, that's taking a leading role in sustainability.
Which is incredible for the planet. It's a good thing. Raising the bar will drive others to become more efficient. It's going to be an iconic vehicle.
So the Amazon fleet consists of electric delivery vans that deliver Amazon packages in your neighborhood. So this pipeline syncs telemetry data from the EDV fleet to Amazon. Let's look into some of the statistics here. So far, we have delivered 10,000 EDVs out of the total 100,000 order. So who, as of October 2023, have driven 62.5 million miles, operating in both North America and in Europe region. Amazon were focused on two primary areas for which they need the telemetry data from these EDVs. Firstly, for the efficiency in the route planning, the accelerometer data, the GPS data, the charging data was needed. And secondly, for the safety reasons, the collision detection, airbag deployed, the cabin and the cargo temperature, the driver seat belt buckle unbuckle status were critical. Peeking into the architecture of the Amazon last mile pipeline. So there are these two streaming pipelines. One is a batch pipeline, other one is a real-time pipeline as part of partner integration that serves telemetry data from the EDVs to Amazon Cloud. So this pipeline syncs hundreds of sensor signals. The batch pipeline creates Parquet files every few minutes into their Rivian account first in the S3 bucket. Then the S3 bucket-to-bucket replication, as can be seen in 9A, replicates the files into Amazon's account. For the real-time pipeline, the data sync is done via an SNS topic. The data is securely transferred using the KMS key on both the sides. And the data on the Amazon side is managed by the Amazon's connected vehicles team. So that completes the deep dive of the four major pipelines. We have seen how MSK plays a critical role in powering these four pipelines. We'll be now doing a deep dive into the MSK cluster and talk about four major aspects of it, vis-a-vis the ecosystem, security, monitoring and observability, and lastly, the cost optimizations. So we provision our MSK cluster using Terraform. So once a cluster is created, how do we create topics? How do we update topics? Or peek into the topic payload, or view schemas, view access control lists, or connectors, or the Kafka consumer groups. So it's using the UI for Kafka, which is an open source tool. It's a primary admin utility tool. We have made like custom SSO integrations, wherein specific Kafka admins have admin privileges, versus the rest have like read-only privileges. Secondly, the cruise control. To set up like hard and soft goals, mostly we apply recommendations provided for rebalancing the topic partitions. For the services, we use the schema registry service for data governance and for schema validation. Since Avro is like native to Kafka, we have seen like 70% reduction in the bytes in metric using Avro with snappy compression as compared to plain JSON. And the last service is the Mirror Maker service. The Mirror Maker service is used to like mirror the data between a source and destination Kafka cluster topics. Last year, this was like really helpful with the migration of our AWS accounts. And we plan on to be in the AWS managed Mirror Maker as Vidhi already explained. So within Rivian, we have a polyglot team. So like different engineers have different programming backgrounds. So I've listed like some of the technologies our engineers like to interact with Kafka. For the JVM-based, the libRD-based, the event-based Lambda, which is for the event source mappings, and lastly, the open source components using Kafka Connect or REST proxy. How do we make sure the clients that interact with Kafka are provided security with? It's using the Kafka authentication and authorization feature. For the authentication, so all clients should authenticate themselves using either the SASL SCRAM-based authentication or IAM-based authentication. For the authorization piece, instead of relying on the Kafka ACL scripts, we created like an API-based microservice that leverages Kafka admin packages to provide the authorization. So specific SASL users are provided specific produce or consume rights. And lastly, about the data encryption. So MSK has a feature which we have enabled for data to be encrypted in transit and at rest using the KMS key. For the monitoring and observability, how do we make sure our clients monitor their applications to track critical metrics, for example, the Kafka consumer group lag, or the traffic in the topic, etc. So using the out-of-the-box MSK feature for open monitoring for Prometheus, we tap in the JMX and node metrics from the brokers and store them in Datadog. The alerting on key SLA metrics is performed using PagerDuty and Slack. Let's look into some of the statistics. So as can be seen in the center box here, the year-to-date increase in the messages in per second is around 140%, which is proportional to the rate of Rivian production numbers. And last but not the least, let's focus on cost optimization. So early 2023, as more cars were produced, more streaming pipelines were deployed, the cost increased at the same rate. So we had to bring down this cloud cost. The cost optimizations we performed are separated by depending on client side versus broker side. On the client side, the data transfer cost had increased exponentially. So using Cost Explorer, we found that 70 to 80% of the data transfer cost were due to Flink consumer client applications. We will see how enabling rack awareness helped us to bring down the data transfer cost. And secondly, there was an increase in the broker CPU at the same rate. So instead of relying on increasing the instance type, let's say, for example, from M5 2x large to M5 4x large instances, we turned our attention to Kafka producer client compression. On the server side, on the broker side, cost optimization features to reduce our MSK compute and storage cost, we started looking into the MSK tier storage offering. Let's understand the rack awareness here. So AWS customers have to pay for the data transfer cost. This data transfer cost is incurred when data is transferred cross availability zone or cross region. So by default, the consumer will consume from the topic leader partition since consumer is hosted in availability zone 3 and the leader partition is hosted in availability zone 2. The data needs to be transferred from AZ2 to AZ3, which will incur the data transfer cost. So by keeping the consumer clients rack aware, the consumer will instead consume from replica 3 in broker 6, thus avoiding the data transfer and the associated cost. So here, just by setting the broker replica selector class and making the Kafka clients rack aware, by setting the right client.rack config for your consumer, we could see the data transfer cost significantly reduced by 85%. The arrows you can see here is when we deployed the Flink jobs with the rack aware settings. And on the left side, you can see the data transfer cost. So over time, it increased, and then once we had it rack awareness, it decreased at the same rate. Similarly, by setting up the Kafka producer compression, by batching data with, let's say, the linger MS setting with 10 milliseconds or 50 milliseconds or 100 milliseconds, and using the compression type snappy, we could see like 70% reduction in the bytes in metric and 57% reduction in the cluster CPU. For the server-side optimization, we saw a huge potential to reduce our MSK cost, both compute and storage, using the tier storage offering. Our cost calculation projections with our production MSK cluster, we saw around 40 to 45% reduction in the MSK compute and storage cost. We did a load testing in a non-prod environment using this tier storage feature, and we saw the results looked promising. So we plan on to roll out the Kafka 3.6 with the tier storage feature early in Q1 of 2024. So what were all the lessons learned? Firstly, regarding the Kafka transactions. So in the early days, we ran AWS Lambda to produce the data to Kafka. We had enabled transactions. However, due to the ephemeral nature of the Lambda, it couldn't reuse the transaction IDs. That lead to like broker heap of 1 GB going out of memory frequently, causing like broker restarts. Similarly, for our Flink jobs, we had enabled exactly once semantics, but on the deployment of the Flink jobs, we saw producer fencing exceptions. So that's where we had to like turn off transactions, but we would like to like revisit transactions once we upgrade our cluster to 3.6. Secondly, regarding the cross-AZ data transfer cost, it contributed use to our AWS cloud bills, so enabling rack awareness was crucial. The third aspect being the capacity planning. So as more cars were produced, more client applications were increased. We had to scale by increasing the number of brokers on the cluster. We have to reduce retention on the topics, both on the time-based as well as the bytes-based. The fourth aspect being the observability alarms. So the democratization of the metrics were important for our clients. So setting up the right SLOs and SLAs and defining budgets were crucial. Our Rivian core data platform team really helped us to define those budgets in Datadog for critical applications. And lastly, for the access control, to make sure no unauthorized clients get access to the MSK cluster was equally important. So next, for the opportunities ahead slide, I will pass it on to Anirban.
Thank you, Rupesh. So let's take a look at the opportunities ahead. By far, the biggest opportunity for us is how do we scale this ecosystem. Based on current fleet projections, we'll probably have about 1 million vehicles in the next couple of years. And that means petabytes of data. This also means we'll have to add new clusters or brokers to existing clusters, reduce retention, partition the topics differently, and so on. We'll have everything on the table. We'll also have many more apps on our stack. And some of these apps might be different from real-time or batch processing use cases. The fan-in, fan-out rates might be different, or the nature of data it will handle will be different. Vidhi talked about velocity, volume, and variety. Those challenges will be there for us as well. Right now, we are deployed in 2 regions, but we'll have to deploy in more regions, not just in North America, but also in Europe. We looked at Replicator. We'll probably have to take some of the vehicle metadata from our control plane in US and replicate to other regions as well. Cost to operate is a critical metric that we are measured against. We want to continue pushing down the cost of vehicle over its lifetime. And we are super excited to see AWS announce MSK 3.6 and support for tiered storage. And we will go ahead and implement that in Q1 of 2024. There's a lot of opportunity for us with the toolkit support. Right now, we are using Kafka admin primarily and some homegrown tools. But what we lack is basically ability to view across clusters, across regions. As we deploy in multiple regions, we will need to see better the vehicle traffic, the nature of the data that is being sent. And finally, we cannot not mention AI-based innovations. We are looking aggressively at LLM-based tools to get better MSK metrics and provide that for our DevOps and engineering community. Now, we are extremely bullish about Rivian's growth and success enabled by AWS services with managed services Kafka. We see innovative use cases using our connected vehicle model as we continue to add value for our customers. Thank you. I'll turn it over to Vidhi to wrap it up.
Thank you, Anirban and Rupesh, for sharing this Rivian story with us. It's amazing to see how Rivian is transforming the automotive industry with their software-defined vehicles, and how AWS and MSK are enabling Rivian to reimagine the future of driving. We'd love to hear streaming use cases in your organization and how we can help you, support you to get more value from your data. We have quite a few streaming sessions lined up that we'd encourage you to attend and learn more about our streaming services. We'll be around to chat, hear from you, take any feedback, or answer any questions. So with that, thank you so much for joining us, and we hope that you have a wonderful reInvent. Thank you.